for this problem, we're going to use the squeeze theorem to evaluate limit x approaches 0, x squared sine 1 over x. I think we might have done this in lecture notes, and maybe there's already a video on this, but let's go for it. Okay, so here's my solution, which could be thought of as a proof. For the squeeze theorem, what I need to do is I need to construct an inequality. And if I see sine or cosine, that's where I begin. I mean, it's not a rule, but it's often the case for anytime I'm trying to develop an inequality that involves sine. I do this. I start here where I notice that sine, or I keep in mind that sine has a minimum value of -1 and a maximum value of 1. The minimum is -1, the max is 1. And then that's not, in the middle is going to be our function x squared sine 1 over x. So what I do is I multiply by x squared. So I get -x squared less than or equal to x squared sine 1 over x, and that's less than or equal to x squared. Okay, so I have this pretty involved looking function here in the middle. It's squeezed between two functions that I'm familiar with. So I need this inequality. What I'm not going to do is know, and I'm going to erase this before, I'm not going to put limit in front of everything. Why am I not going to do that? Because we do not know that the limit of this inside function exists. We do not know it exists. So if I do what I just showed there, that's assuming the limit of the inside function exists, and I know it. But it doesn't. I mean, it's not. It doesn't. I don't know it exists. I'll tell you one thing: that if I took away the x squared, we showed that limit of sine 1 over x does not exist. So don't just throw limit. It's not using the squeeze theorem anyway. Squeeze theorem doesn't do that. So the squeeze theorem does this. They say, okay, we'll take the limit of those two outside functions, which, that's not a problem because those are polynomials, and I can evaluate those limits by directly substituting in x equals 0. So what happens is that now we see that limit x approaches 0 of -x squared equals limit x approaches 0 of x squared, which equals 0. Therefore, the limit of the inside function, what I'm calling the inside function, the one that's being squeezed or sandwiched by those two other functions, that equals 0 by the squeeze theorem. And I'll put a little box like I'm declaring victory. Okay. Does anybody have a question about that? I mean, I've done the problem before, so I've sort of go through it quickly now. I mean, we've done a couple of examples, and there's one video at least on that. If I start another one, then anyway, I think I'm going to stop this video and I'll start